and welcome back to StudyOnion. And today we're going to be talking about observing the sun. Let's get started. So when you're observing the sun, there are 3 safe ways in which you can look at the sun without causing temporary or possibly permanent blindness. The first one is a H-alpha filter, and this is a filter which absorbs all the sunlight apart from a very narrow range of wavelengths which is centered on a particular spectral line of hydrogen. The wavelength that is let through is at 654 nanometers. Another option, if you are looking to observe the sun, is telescopic projection, which requires the use of a baffle, which is just a card with a small hole, to absorb most of the solar radiation before it enters the telescope. And finally, you could use a pinhole camera. Now, the projection card needs to be a long way away from the pinhole to obtain a reasonable sized image. But even with a small homemade pinhole camera, you can observe the sun. It will not be in as much detail as the larger camera, but you will be able to see a shadow of the sun. Now let's talk about sunspots. There are 2 parts of a sunspot. You have the umbra and you have the penumbra. The umbra is the cooler region and the penumbra is the slightly less cool region. So the umbra is at around 3,800 Kelvin. And penumbra will be around 5,600 Kelvin, while the normal photosphere, which is the layer that these sunspots are usually present on, is around 5,800 Kelvin. On most clear days, observers can see several sunspots on the surface of the sun. These are the cooler areas that correspond to the strong, localized magnetic fields that inhibit the upper motion of convective solar material and prevent it from reaching the photosphere. So this is basically saying that the high intense levels of magnetic activity in the photosphere near the sunspots actually cause the areas to be cooler because it prevents the higher temperature material from reaching the surface of the sunspots. By observing the apparent motion of the sunspots across the solar disk, it's possible to determine the sun's rotational period at different latitudes and therefore deduce that the sun does not rotate as a solid body. It rotates at different speeds at different parts on different sections of the sun. Its rotational period varies from the 25 days at the equator to the 36 days at the poles. And these are 2 values that are really good for you to know, because then when you are doing a calculation to calculate the sun's rotational period, you are able to know that the value will be in between roughly 25 and 36. You may ask, how do you calculate the sun's rotational period? The sun's rotational period can be determined through the recording of a position of the sunspot approximately every few days. The longitudes of the sunspots on different days can then be found, and the way you do this is by overlaying a transparent grid over the sun and using that grid to calculate the longitude at that particular point where the sunspot lay. If the difference in longitude of the spots occurs in a specified time interval, you can then find the rotational period. And this is done using a formula. The formula that you have to remember is that T divided by delta T is equal to 360 divided by delta L. So T here stands for the rotational period, and this is your capital T. Your delta T stands for the difference in time interval. And I'm going to say here that delta means difference. Whenever you see that in an equation, delta means difference. So, for example, in physics, you have your delta theta, which is your change in temperature. Here you have your delta T, which is your change in time. You have your delta L, which is a difference in longitude, and so on. And then again, as I said just then, delta L is equal to your difference in longitude. This means that by substituting these values into the equation after overlaying a grid, you are able to see the sun's rotational period at that specific latitude of the sun. This is then repeated for different times and different longitude differences, allowing for a more accurate value to be calculated and allowing for the mean solar rotational period value to be calculated. And this can be done if you vary the longitudes. So, to summarize, the 3 ways in which you can observe the sun safely are: alpha filter absorbs all the sunlight from a very narrow range of wavelengths centered on a particular spectral line of hydrogen. The telescopic projection method uses a baffle to absorb the solar radiation before it enters the telescope. On most clear days, observers can see several sunspots on the surface of the sun. These are the cooler areas of the photosphere that correspond to the strong, localized magnetic fields that inhibit upward motion of convective solar material, preventing it from reaching the photosphere. By observing the apparent motion of the sunspots across the solar disk, it is possible to determine the sun's rotational period at different latitudes and deduce that the sun does not rotate as a solid body. Its rotational period varies from 25 days at the equator to 36 days at the poles. For sunspots, the umbra part of the sunspot has a temperature of 3,800 Kelvin. The photosphere has a temperature of 5,800 Kelvin, while the penumbra part of the sunspot has a temperature of 5,600 Kelvin. To calculate the sun's rotational period, use the formula T divided by delta T, which is equal to 360 divided by delta L. Here, T stands for the rotational period, delta T stands for the time interval, and delta L stands for the difference in longitude. This can then be repeated for different times and longitude differences to calculate the mean solar rotational period. Thank you very much for watching, and next week we'll talk a little bit more about solar astronomy. But for now, bye!